Thank you. Hello, everybody. Now, the grown-ups think you've come here to learn about science, but actually, I've come here to show you how to make a great big mess in the kitchen afterwards, scientifically. Shall we start with the custard? Yeah? Good, okay. Now, you might think exploding custard is just some kind of silly joke. I'm now going to show you a very frightening photograph. Are you ready for this? This is a scary photograph. It's a photograph of the factory where this brand of custard powder used to be made. I say used to be made because look what happened to the factory. In 1981 it was completely destroyed by a huge explosion. And guess what exploded in the custard factory? And who wants me to show you how it happened? Okay, people at the front, are they putting their hands up? I'm not sure they are. Okay, let me show you. Custard powder is a very fine kind of flour called corn flour. That's all it is. It's corn flour, this kind of custard powder. It's got yellow food colouring added to it. You only see the yellow colour when it's wet. And it's got vanilla flavouring. Otherwise, it's corn flour. Shall we set fire to some? Yeah. Okay. People at the front want me to set fire to some? Okay. Half-hearted, yes, that was. Okay, let's see. Right, take cover. Get ready, and let's have a look. You ready? Hang on, nothing's happened. Nothing very much. Can you see it's gone black round the edges? Yes? It's only gone black round the edges. Now, you've learnt enough science in school, I'm sure, to understand that before things can burn, let alone explode, they need air. Oxygen in the air is necessary for burning. Now, because this powder is in a great big mass on the spoon, it only went black, it only burnt round the edges. Let's try sprinkling it through the flame in little bits, shall we? Because then we'll have more edges, won't we? Watch the flame carefully. Can you see little flashes and even some sparkles perhaps in the flame? Could you see that? Because each separate grain was so tiny, the air could get all the way around it and it burns in a flash, poof, like that. Every separate grain. Would you like to see me make about 1 million grains all flash at the same time? Yeah? Okay, now I'm just guessing what 1 million grains of custard powder look like. If I push this piece of drinking straw into the powder, I've filled it with custard powder up to about there. I'm going to blow this through the flame now. People sitting over there are going to get an extra good view of this because it's going to be travelling in their direction, okay? You ready? I can see people jump then. That was pretty pathetic. You all want your money back now, don't you? That was a very, very small version of the custard explosion that destroyed that factory. Don't worry, we're going to do a much bigger one later. But what happened in the factory was that the machinery processing the custard powder went wrong. And the great cloud of custard powder went up into the air in the factory and caught fire. And millions and billions and trillions of grains of powder all flashed at the same time. And that's what happened to the building. Now, the more observant young people here will have noticed we've got a big plastic funnel here into which I could get an awful lot of custard powder. And you might have noticed I've got this rubber hose leading to my powerful air pump. Right? I can see young minds working now. Are you just picturing what's going to happen when I do that? Yes? Yes? Now, you probably really want to see me do that, don't you? Do you want to see me do that? Yes. Do you really want to see me do that? Yes. Very good. And that's why we're going to do it at the end. And that's going to make sure nobody leaves early, and also for you to start thinking about your feelings, because you're feeling curious, a sense of awe, people in the front row are feeling very nervous, but feelings are really what make scientists do science. When you learn science at school, you can get the wrong idea. You can think it's just about learning stuff and remembering information. There's a lot more to science than that, and that's the aspect of science we're going to look at this evening. Feelings as well as facts. Okay, good. Now, I've got plenty of good news for you this evening. We've got a mixed audience. We've got grown-ups and we've got young children. And I've got this theory about grown-ups. My theory is that the older you get, the more boring you get. Does anyone agree with my theory? Put your hand up if you agree with my theory. Okay, good. I've got some friends here. That's excellent. Now let's see if we can prove that. Okay, I'm going to try and prove that this evening in various different ways. But the first is just a sort of thought experiment. How many times have you seen a small child in the bathroom getting washed with a grown-up standing behind them at the wash basin, and the grown-up is saying to the small child, it might have been you, "Stop messing about with the water, just wash your hands." If you've ever heard a grown-up say those exact words, put your hand up. You see, I've asked this question in different countries, in different languages all over the world, and it happens everywhere. And the reason is that when you're very young, water looks wonderful. And as you get older and more boring, you stop noticing. And I'm really serious about that. That is really sad. Because noticing things and thinking about the wonder of things is what science is about. And it's one way that children are better at it than grown-ups. Seriously. So let's have a look at some water now. Let's just take this off here. I'm going to put this plastic tray on this projector and put some water in it. And we'll see it on the screen. Okay, you're a fairly quiet audience tonight, but I think I could hear some indrawn breaths there. People thinking, wow. Who was thinking, wow? Good. Why is it the young people putting their hands up and the grown-ups aren't? You see, I'm beginning to prove my point here. Except that grown-ups don't like putting their hands up because grown-ups don't like being wrong. And we're going to come to that later as well. But even the most boring grown-ups, when they're lying in the bath sometimes, dabbling their fingers in the water, watching the shadows of the ripples on the surface bouncing off the side of the bath. Really interesting. And when they bounce off the side, they seem to be coming from behind the side of the bath, don't they? Really interesting. And when you're doing this, you hear someone banging on the door outside saying, "Stop messing about, get washed." I'm going to show you another way that young people are better at science. And that is in making observations, in noticing things. Grown-ups are rubbish at noticing things, am I right? Yes, children are really good at noticing things. Let's demonstrate that to the grown-ups now. Let's try not to trip over these wires. Anyone here like Rice Krispies? I like Rice Krispies. Let's put some Rice Krispies in the water. And we're going to see them floating on the surface. And what I want you to do, I want you to call out anything interesting that you notice happening. Now, don't call out Rice Krispies, because we know they're Rice Krispies. But if you see anything interesting happening, and there's no right answer here, lots of different things you'll notice. Will you please make some noise now, children, because you've been very quiet so far. Make lots of noise. Shout out what you can see on the screen. Will you do that? And show the grown-ups how good you are at noticing things. Right, go. Let's see. What can we see? Yeah, we know they're Rice Krispies. Anything else? Yes? Come on, anything else? Yes, very good. Very good. Yeah, don't put your hands up, just shout. Yes? Okay. Okay, stop. That was very good. Shh, shh, shh. Excellent. You see, again, another difference between children and grown-ups. If we had only got a grown-up audience tonight, we would have had silence then, with maybe one finger up on the back row with a hesitant suggestion. You were shouting out lots of interesting things that you noticed. They're sort of bending the light, they're making funny shapes, look a bit like insects, they're making patterns. Sort of, you can see pictures in that, can't you, as well? They're going snap, crackle and pop, like it says on the packet, as the air bubbles start to come out of them. And they're sticking together. That's interesting. They're sticking together. Who noticed that? I think quite a few of you did. That's good. Okay. Wow. Now listen. Do you know any grown-ups who like to think they know everything? Yes, do you? Ask them why Rice Krispies attract each other in your breakfast cereal milk. Okay? Because they may not know. I've never seen that explained in a single science textbook anywhere. And you ask a quite clever scientist why they do that, you might find they would struggle to give you an immediate answer. It's not very difficult to find out why, but a lot of grown-ups won't know. Now, this demonstrates that grown-ups don't know everything, okay? And grown-ups don't have to know everything. I want you grown-ups to feel more relaxed about science, because you don't have to. Science is about finding out and thinking, and being confident about not having to know about everything, okay? That's quite important. So, would you like me to explain to you why Rice Krispies attract each other in your breakfast cereal milk? Would you like me to? Okay, now, if I do, it'll take about an hour. Would you rather I spent the next hour or so showing you some more experiments? Right, so I'm not here to explain everything to you tonight. Okay? I'm going to leave a lot of things unexplained, because explanations sometimes stop us from thinking, and I want to start you thinking. So I'm not going to explain everything tonight. So there's a little mystery for you, because real science is about mysteries. As a matter of interest, how many people have looked at their breakfast cereal, their sugar puffs, their Wheatie Bangs, whatever it is you have for breakfast, and have noticed them actually attracting each other to the milk? Who's thought about this before? Put your hands up. Now look at that. That's remarkable, isn't it? A lot of young people have, and not a single grown-up. Okay, interesting. Right, we've made an interesting observation, could almost say a discovery. And when scientists make a new discovery or a new observation, sometimes some clever inventor comes along and invents something that makes use of that discovery. And some inventors get stinking rich, don't they? Wouldn't it be nice if we could invent something new together this evening and get stinking rich? Yes? Now listen, can we make a deal? If we're successful in this, will you share the money with me? Yes? If you say no, I won't show you this idea. Do we have a deal? Okay, good. Look at the pattern the water's making on this plastic tray. Isn't it beautiful? Do you ever watch raindrops on a wet window? Again, this is something that children do and grown-ups don't. People studying cancer cells have discovered all sorts of interesting things from watching water drops on glass. Okay, now I've got this idea for an invention, and I want you to help me think about it. Will you all just humour me in this and close your eyes? Close your eyes. Imagine that you're out at sea in a very small boat, and you've got no engine, no sail, no oars in the boat, and the wind is blowing you out to sea. You've got a big problem. All you've got in your little boat... Oh, hang on, wait a minute. I haven't... No, it's all right. Stop, open your eyes. Open your eyes. I've forgotten to show you something. Open your eyes again. Before we get on to that, let me show you something else. Let's try something else. Has anyone tried putting washing up liquid on your breakfast cereal? No? Okay, you have. You'll know the answer to this next experiment then. Okay, if I'm going to put some washing up liquid in the centre of this mass of Rice Krispies, what's going to happen? Any ideas? You can shout out if you want. What do you think's going to happen? Okay, quiet. Hold your breath. Yes, who got that right? Some people did. They have put washing up liquid on the Rice Krispies. Okay, right, now, okay, there's another observation we've made. Sorry, I meant to show you that before. Sorry, let's move on and try and invent something that makes use of that. Okay, start again. Oh dear, let's put some water in here again. Right, here we go. Right, there's our tray of water. Now then, where were we? We were out at sea. Close your eyes again. You're out at sea, drifting out to sea, no motor, no sail, no oars. All you've got in your boat is a bottle of washing up liquid. Any ideas what you're going to do? Open your eyes. Who's got a suggestion? What would you do with the washing up liquid? Nice and loud. Put it in the water. Who else would do that? Put the washing up liquid into the water, okay? Would you put it into the water in front of the boat or behind the boat? Behind the boat. Why? Because you think the boat might move away from it. Yes? Who's thinking that? Let me see. I want to see people thinking. Good. People thinking. Now, if this works, we are going to get rich because boats won't need engines anymore, will they? Right? You imagine these great ships gliding silently across the ocean, leaving a trail of froth behind them and pollution. We'd have to think of something to cure that. Who thinks this invention is going to make us rich? Good, I've got some friends here. Who thinks it's not going to make us rich? Should we try it? Yes? Okay. They used to, on that TV show, Blue Peter, they used to say, here's one I made earlier. Do they still say that? I don't know. Here's one I made earlier. A little tiny paper boat, cut out for one of my business cards. If anyone wants one of my business cards, they're on the table at the back there afterwards, by the way. It's a little cardboard boat. They put it in the water. Now you can see it a bit more clearly. Oops, what's it doing? There we are. That's it. It's not going anywhere. It's just sitting in the water. Here's another little boat. And this one, I'm going to put some washing up liquid on the back and see if that makes a difference. You've all gone very quiet because you're wondering what to spend the money on if we're successful, are you? Yeah? Sweets, I don't know. Okay, let's see if this is going to work. Hold your breath. You ready? Oh my goodness. Yes? Yes! Who's going to try that at home? Excellent. Right. We have a result. Right, now are we going to get rich? Have you seen that TV program, Dragon's Den? You have an invention like this, you take it on the show and you ask these guys to give you some money to develop your invention. Now they're pretty tough, these business people, aren't they? Pretty tough, scary people. They're going to look at our apparatus and they're going to say, well, thank you, Ian. It's very impressive, but at the moment it's only working on a small scale with a small boat. So we're only going to give you a small development budget, maybe just £1 million, something like that. But we want to get seriously rich, don't we? Yes? So we want to see if it works on a big scale with a big boat. Are there any lakes around here where you can get into a rowing boat and maybe try this out? Don't go putting lots of washing up liquid into the pond because it's very poisonous to water creatures. For example, those little insects that run about on the surface skin of the water. Have you seen them? Pond skaters, one kind is called. Good. Who's noticed them? Good. You're good at noticing these things. Why is it that these little insects can run about on the surface of the water and you can't run about on the surface of the water? Is it because they're smaller than you, or is it because they've got greasy feet? You think it's because they've got greasy feet. So when you go down to the pond, take a big tub of margarine with you. Will your parents be pleased? All these ideas I'm giving you for experiments to try afterwards. Take your shoes off, cover your socks in margarine, and see if you can run about on top of the pond, okay? Is anyone thinking that's not a good idea? Has anyone changed their mind now? Is anyone thinking maybe size has got something to do with this? Yes. Is anyone thinking maybe that's why a small boat might behave differently from a big boat on the surface skin of the water, the surface tension? Maybe, are you thinking about that? You see, I'm not going to say any more about this now. I'm going to move on and let you experiment at home. And, you know, we did make this deal. If you get rich from that, you've promised to get in touch with me, find my email address or my business card, and share the money. There we are. Actually, I make my living, my website's there if you can read it. I make my money, my income from designing interactive exhibits for science museums mainly. I do this show as a sort of a sideline. And I learn a lot from doing this show, from how people see things. I need a volunteer from the audience to help me with the experiment. You put your hand up really quickly. Would this girl like to come out the front? Come up these steps here. Okay? Can I just ask you to just keep an eye on children on the stage? You know, I don't want anyone falling off the stage. We'll try not to have anyone falling off the stage. Come and stand here and hold this. Well, I'll show you this bottle. What we're going to do is we're going to hold it like this. It's full of water, and it's got, that actually looks like red tomato sauce, doesn't it, in a sachet? And that's what it is. And it's just floating in the water. Sometimes I have to put paper clips on one end so that they're, you know, not floating too high. Just get the balance of it, only just floating. The air bubbles in the tomato sauce are making it float. Now I'm going to ask my friend here to squeeze the top of the bottle with both hands and see what happens. You're going to increase the pressure in the water. Okay, that's going to squeeze the air bubble, isn't it? Smaller perhaps. What do you think is going to happen? Yeah? You can shout out if you like. What's going to happen? Okay, let's see if it does. Squeeze the top of the bottle. And keep squeezing. Now, if she stops squeezing, what's going to happen? Goes back up again. Right, that was good. Okay. Now, let's try another experiment. I'm going to ask my friend now to squeeze the bottom of the bottle. Quite a few times in this show, I'm going to be asking people to predict what's going to happen. Now, you'll probably notice that the grown-ups not putting their hands up, because as we've said, grown-ups don't like being wrong. I've tried to convince them that it doesn't matter, but it's very hard to convince grown-ups that it's okay about being wrong. So try and encourage your grown-ups to join in with this. How many people think that it will sink if she squeezes the bottom of the bottle? Put your hands up. Okay, you think it will? Okay, good. Put your hands up really high. You know, go for what you believe. Who thinks? Put your hands up if you think it won't sink if she squeezes the bottom of the bottle. I think we have a majority there. Lots of grown-ups not voting, of course. Okay. Okay, squeeze the bottom of the bottle. Right. It feels good when you're right, doesn't it? Yes? Even when lots of people seem to disagree with you. If lots of people seem to disagree with you, does that mean that you must be wrong? No. You can think for yourself. That's what science is about. Next experiment, we're going to squeeze the middle of the bottle while it's on its side. Now then, how many people think it won't go from that end to that end? Put your hands up high. Okay, nice and high, that's the way. Lots of people seem to disagree with you, but that doesn't matter. How many people think it will go from that end to that end? Okay, again, about 50-50. Okay, squeeze the middle of the bottle. I'll squeeze with you. You're squeezing really hard? I am too. It's not moving. Right. Who's going to make one of these at home? Really good. Well, I'll tell you what you can do with it. You can pretend it's a naughtiness detector. If you're pointing at anything naughty, it'll sync. Let's see if it works. Oh dear. Let's try again. Oh dear. You can have great fun with a naughtiness detector at home, can't you? Yes? Who's going to make one? Good. Don't forget to put wire paper clips on one end to make it heavy enough so it's almost already sinking. And when you've made this at home, and you've played with it for a bit, experimented. What's the difference between playing and experimenting, by the way? Interesting, I'm not sure. Climb up onto the roof of the house, stand on the edge of the roof like this, and then jump off. And on the way down, you can try a really interesting experiment. You can squeeze the bottle to see if it will sink while you're falling weightless through the air. Who thinks it will? Who thinks it won't? I'm not going to tell you. Okay, go and sit down. Well done. Thank you. Give her a clap. That's good. This is just an ordinary plastic bottle. And yeah, lovely. Thank you. We'll look at that in a minute. It's got water in it and it's got air here. Now, again, you've learnt about states of matter in school. You've learnt about solids, liquids and gases, haven't you? And the bottle obviously is a solid. The water is a liquid, and the air inside is a mixture of gases. Are you clever enough to tell me the names of some of the gases we've got in here? Yes, give me one. Argon. Wow. Yes, we have a little tiny bit of argon. Yes, yes. Oxygen. Quite a bit more oxygen. Yes, boy here. Carbon dioxide. We hear a lot about carbon dioxide, and a gas beginning with N. N. Right at the back. Little girl there. No. Okay, shout. Okay, everyone, shout out. Gas beginning with N. Nitrogen. Right. Okay. There's another gas in there, quite a lot of it, and we always forget about mentioning it. It's a gas, very common gas, beginning with W. Yes. Water. Water vapor. It's a gas, isn't it? And there's lots of water vapor in there. Okay. Now then, when water vapor changes back quickly from a gas to a liquid, sometimes it happens on a cold day, and you get windows steaming up in your school classroom, don't you? Yes? When it's warm and sort of humid, damp inside and cold outside, you get water vapor condensing on the cold glass as liquid water. When that happens in the sky, we get a cloud. Did you know that clouds are actually made of little tiny microscopic drops of liquid water? That's what they're made of. If you jump out of a plane with a magnifying glass, interesting experiment on the way down, and again, you can look at the clouds as you're falling through with the magnifying glass, and you'll notice that the clouds are made of little tiny droplets of liquid water, very small. Let's try making a cloud in the bottle. I'm going to squeeze the bottle very, very hard and release the pressure. Tell me if you see a cloud. Are you watching? Did you? Didn't work. Much more clever sounding way of saying that is saying it's a negative result. In the sky where real clouds form, there are tiny, tiny solid particles, dust particles, smoke particles, and they make a big difference to cloud formation. And you can demonstrate that, because I'm going to make some microscopic carbon particles inside the bottle, simply in the form of smoke. If I can get a match to strike. Burning nicely. You just drop it into the bottle and it's gone out in the water straight away, but it's introduced a tiny bit of smoke into the gas mixture here. Let's see if that makes a difference. If I hold it in the light so you can see it more clearly. Okay, I'm Watch when I release the pressure. Tell me if you see a cloud. Oh! What happens if I increase the pressure again? What's going to happen to all those microscopic drops of liquid water? They're going to evaporate immediately back to water vapour. So I can make the cloud as fast as I like. Actually, do you want to see a green cloud? Amazing, isn't it? You might have seen something like that before. When you're drinking a fizzy drink, bottle of fizzy pop or something, you can't drink all that, so you drink about that much, and you put the top on. And of course, these drinks are fizzy because they've got carbon dioxide gas under pressure dissolved in the drink. And the fizzy bubbles come out, and after a while, after you screw the top on, the pressure increases again, and the bottle goes all hard and tight. You take the top off again, it goes psh, and as that pressure drops suddenly, you see a cloud in the bottle. Who's noticed that before? You see, now you'll notice it again after I've shown you this. That's the other thing about this sort of science. You start to notice things that you hadn't noticed before, and it's a new way of seeing the world, and it really does enrich your life. Good. Yeah, I was just going to show you this. It's quite hard to join two bottles together to do this, but I've made a sort of a tornado, a whirlpool. It's just like the water going out of your plug hole, isn't it? Yeah? How many people like watching the water going out the plug hole? I know the children, not the grown-ups, I know. Okay. How many people have been told that when the water goes out the plug hole, it always goes round anti-clockwise in the northern hemisphere? On the other side of the world, it goes round in the other direction. Put your hand up if you've heard that. Let me see. Okay, quite a lot of people have heard that. Put your hand up if you've checked it for yourself with your own plug hole. Good, we've got some scientists here, even some grown-ups have tried it. That's very good. Okay. Did anybody try it at home with your own plug hole and come to the conclusion it doesn't seem to work? My plug hole seems to go around either way. Anyone? Now, a lot of people seem to disagree with you. Does that mean you must be wrong? Not necessarily, no, and you are right, because it's not true. Not everything clever people tell you is true. How about that? This is very controversial stuff, isn't it? Sometimes not even everything teachers tell you is true, and you can think for yourself. Now, when grown-ups tell you something, and especially when teachers tell you something, you must pay very careful attention, because they're likely to know a lot more than you. But you can always, always think for yourself. If the teachers had always been right through the ages, if the science teachers had always been right through the ages, science would never have developed, would it? It would never have changed. Think about that. I can make it go round anti-clockwise. I can make it go round clockwise. Okay, there you are. It's going on either way. I was starting it off, but when you pull the plug out, you move the water slightly. Okay, it's impossible to have the water completely still in a kitchen sink, in a bathroom wash basin. On a large scale, with hurricanes and tornadoes and ocean currents and weather systems, it is true. They do. Tornadoes do and hurricanes do go around anti-clockwise north of the equator and clockwise south of the equator. On the equator, they don't know what to do. But it's a matter of scale. Good. I was talking about how thinking scientifically can change the way you see things. Let's do an experiment with a toilet roll, just to prove that every room in the house has got something we can experiment with. And this is going to be a competition between children and grown-ups, right? We're going to see whether who can get the most correct predictions, the children or the grown-ups. Here's the experiment. The toilet roll is sitting there. I'm going to hold the end of the paper like this, and I'm going to pull it horizontally at that speed, like that. You got it? I'm going to hold the paper here and pull it like that. And you've got to tell me what's going to happen here. There are three possibilities. The toilet roll could stay where it is and just go round and round, or the toilet roll could come this way, or the toilet roll could go that way. Don't tell the grown-ups, okay? You've got to decide what you're going to vote for. Has everyone decided? Everyone's got to vote. And all the grown-ups have got to vote, because this is a competition now against the children. Hands up! Who thinks the toilet roll will stay where it is and just go round and round in one place? Hands up. Okay, now not many hands, and some people are looking around thinking, lots of people disagree with me, I must be wrong, so the hands are coming down again. Put your hands up high if you think that. Okay. Because it's really good when you're right. Hands up who thinks the toilet roll is going to come this way. Okay, hands up nice and high. Okay. Hands up who thinks the toilet roll is going to go that way. All right, lots of you. Okay. Right, now, perhaps I won't show you. I could say go away and look it up in a book, but what would you look it up under? A for Andrex? I mean, I don't know. It's some things you can't find out in books, can you? Do you really, really, really want to know now? You really, really do, don't you? And that feeling is what makes science happen, that wanting to know. Shall we do it? Okay. Hold your breath. It came this way. How many people got... Okay, hang on, wait a minute. How many grown-ups got that right? Hands up high. 1, 2, 3. Okay, hands down. How many children got that right? Definitely more children, I think. Did we give the children a clap? Very good. Okay. Okay, good. Definitely were more children then. Now, everyone's looking really cross, actually. They're thinking, well, he didn't pull it properly. Shall I do it again? How do you want me to do it? Harder. It's cheap toilet paper. Let's try again. No, it still comes this way. Any more ideas? Really slow. Yes, good. Any more ideas? Upwards. Okay, some scientists want me to pull it upwards like this. Okay, you really want to see it go that way. Go that way. Put your finger in the air and point. Will it go this way or that way? Let me see you voting with your fingers. Let me see. There's someone pointing at the ceiling. That's interesting. Okay. Hold your breath. Yes. Okay. Have you ever cheered a toilet roll before? You see, this kind of science can enrich your life. This is the point. Even in the loo. Okay. Very good. Shall we have another competition? Children against grown-ups. I've got another one we can do. Okay. Right. Okay. Stay there. Okay. All this apparatus, there's nothing I'm showing you today you can't try at home, because all this stuff is just simple stuff you've got at home or can make at home, including this very delicate balance. There's a pin through here, bent paper clip. You can see what I made the bucket from, plastic bottle. Bit of blue food colouring to make the water pretty. Lump of plasticine to balance it. If I just touch the bucket, it's so sensitive it tips the balance. But I'm not going to touch the bucket. All I'm going to do is to dip my finger into the water without touching the bucket. And you've got to tell me if the bucket's going to move, and if so, which way. Have you all thought about that? Interesting, because you've never seen this before, and it makes you think. So I'm going to dip my finger in the water without touching the bucket. The bucket could stay still and not move. Or the bucket could go down, or the bucket could go up. Are you ready to vote? Okay, and watch, make sure the grown-ups are voting as well. They're looking really worried. I can see their faces, because they don't want to be wrong. Hands up who thinks the bucket won't move. Hands up who thinks the bucket will go down. Hands up who thinks the bucket will go up. Interesting, very interesting this is for me. If I said I wasn't going to show you, you would be really cross, wouldn't you? You want to know, okay? Hold your breath. Hold your breath, let me hear you, hold your breath. That's it. Okay, some people are very pleased they got it right. Okay, let's try some more experiments. Let's try dipping a spoon in. Shh, 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 shh. Let's dip a spoon in. Who thinks it will go down? Who thinks it won't go down? Let's see. Doesn't seem to be moving. Wait a minute, wait. Watch the plasticine, watch. It did go down, but only a tiny bit. Why? Is it because the spoon is made of metal, or is it because the spoon is very thin? I'm not going to tell you. You can talk about that afterwards. Interesting to discuss. Let's try another experiment. Now this time, I'm going to make a prediction as well. I'm going to predict that the great majority of you are going to get this next one right. And I'm going to make this prediction because I've never met you before, and you've never seen this before, but I've done this so many times, I learn a lot about how people see scientific phenomena. So this is very interesting. Educational experiment. I'm predicting that most of you are going to get the answer right. Not all, but a lot of you are going to get the answer right. I've got them perfectly balanced. Now, I bet you've guessed what I'm going to do. I'm going to bring the water up over the spoon without touching it with the bucket, and you've got to tell me what the spoon is going to do. It could stay still, it could go down, or it could go up. Okay? Hands up who thinks the spoon will stay still. Hands up who thinks the spoon will go down. Hands up who thinks the spoon will go up. Okay, hands down. I was using a very even tone of voice. I was trying not to give anything away. Do you want to see what happens? Yeah. You ready? Hold your breath. Yes. And I was right as well. How about that? Good. Now, I'm hoping you remember lots of experiments to try afterwards, but this is one I really want you to remember. It's a red cabbage, okay? Rush out to the shops tomorrow morning, first thing, because all the shops in Newcastle are going to sell out of red cabbages tomorrow morning, so be the first to get your red cabbage. Seriously, this is a great experiment to try at home. Break off some of the leaves from your red cabbage and put them into a jug and pour on some boiling water from a kettle with a grown-up helping you. And after a while, the liquid changes colour. You've made a lovely nutritious drink called Cabbage Aid. This is too dark, you can't see the colour, so I'm just going to dilute it a bit. Let's see if that's a bit better, yes. Okay, let's have a look at what we've made. It's very, very, very good for you, this drink, but it tastes absolutely horrible. Interestingly, I wouldn't call that red. Can you see the colour of that? It's a bit dark, isn't it? Maybe I should dilute it a bit. Let's just dilute that a little bit more. There we are. I wouldn't call that red. It's a sort of purple colour, isn't it? Interestingly, when I do this experiment in different parts of the country, I get different results. When I do this in some areas where the tap water is very acid, it comes out bright red. When I do this in London, where the tap water is very alkaline, the opposite of acid, it comes out bright blue. London people don't eat red cabbage, so if there's anything less appetising on your plate than red cabbage, it is blue cabbage. Because that's what happens when you boil it in London tap water. It seems to be sensitive to acidity. Now, I've actually got some vinegar here, and vinegar is an acid. I've got some pickled cabbage here, pickled in vinegar, and it's reddish, isn't it? Okay? That is red cabbage. If I put some vinegar, some acid into here, what would you predict is going to happen? Yeah? You think it might go red? Let's see if it does. Who's going to try that at home afterwards? Okay? Looks like rosé wine, doesn't it? You could give that to your parents for a drink, couldn't you? It looks very nice, but it's cabbage water and vinegar. Okay? Let's do it again. Watch this one change colour. Okay, so you're going to try that at home. Just cabbage, water and vinegar. Now, would you like me to teach you how to make that go blue? Yes, because you can. It's very easy. When you're in the supermarket buying your red cabbage, ask for some bicarbonate of soda. Can you all say that? Bicarbonate of soda. It's a nice, safe, interesting chemical which has a salty taste, and it has the opposite effect to an acid. Let's put some in here. Okay? Oh my goodness. Who likes messy experiments? That is a messy experiment, okay? Goodness me, what happened there? Well, let's put a bit more in, and I think we'll see it definitely does go blue. Okay, now two things happened then. The colour changed because the cabbage water is sensitive to acidity, but it fizzed as well. That was nothing to do with the cabbage, that was a chemical reaction between the bicarbonate of soda and the vinegar, the acid. Now, we made a gas, and you're going to tell me the name of the gas. You're going to deduce the name of the gas from the chemical name bicarbonate of soda. Sodium bicarbonate. Which gas sounds a bit like that? Yeah? A gas. Yes? Clever boy. How old are you? 6. Well done. Well done. Great. Carbon dioxide. That's what we made. Now then, I'm going to show you another experiment involving carbon dioxide, and this involves small explosions. You're going to have to be very brave to volunteer to help me with this. Oh, by the way, sorry, after someone's helped me with an experiment, what I want you to do is to remember to go to the back to Sam, who's sitting at the back there. She's got her hand up. Wave again, Sam. Go and give your name with your parents to Sam, because we're making a film of this and she just wants permission to use you on the film. Is that okay? Could you go and do that? Okay? Okay, now I need 6 volunteers, but you've got to be tough for this. It involves explosions, okay? Okay, little boy in blue, okay, yes, you look tough and brave. Okay, boy in green, yes, you come out. Who else looks tough and brave? We need some people further back. There's a girl in black there on the end of the row. Yes, do you want to come out? Yeah. How many have we got? We've got 3 now. And 4 here for you. Take 1 each. Okay. Okay, now these film containers, can I just borrow yours a minute? They're half full of water. Don't spill the water. Can you manage to get the top off for me? Okay. If you can't, I'll help you. Okay. And don't spill the water. Hold the container and the top. Okay, you've got it off? I'll do it for you. There's yours. Hold it. There's yours. You've got yours off. Okay, actually what we're going to do, I'll show you what we're going to do. I've got some tablets called Alka-Seltzer tablets, and they're these tablets that fizz when you put them in a glass of water. Have you seen those? Watch, there's the tablet. I broke it in half actually. And can you see the bubbles going up? They're actually bubbles of carbon dioxide, because that tablet contains 3 different white powders. It's got aspirin to make us feel better. It's got a dry white acid powder, like vinegar, only it's a dry powder. And it's also got our old friend, bicarbonate of soda. Now when the acid powder and the bicarbonate of soda are dry, they don't react together. But when they dissolve in the water, they start to react together to make a gas called, what's the gas called? Carbon dioxide. Okay. Now when that happens inside the film container, it's going to increase the pressure until eventually the pressure gets so great, it's going to pop the top off. Now we don't want the top to hit you in the face, because that would be dangerous, okay? So what we're going to do is we're going to aim it at them, okay? This show is aimed at a family audience. All practice holding your film containers like this, and we ought to have a prize really for the one who can hit the cameraman at the middle, okay, at the back there, okay? Or you can aim at anyone you like, you can aim at anyone you don't like, okay? See how far you can shoot. Don't aim at me, okay? You're aiming over there, are you? Okay. 45-degree angle for maximum range, right? I'm going to come along with the tablets and just step back a little bit so I can come in front of you, and I'm going to put your top on, okay? Give me your top, okay? This is where I must be careful not to fall off the stage, okay? Just aim it over there. That's good. Okay, give me your top. Give me the top. Hold it away from your face. Okay, that's good. That's good. Hold it away from your face, that's good. Okay. Okay. Okay, put them on the table when they're popped. That's good. Okay. There's some more here. Give me your top. Whoops! Oh, you're shooting me. What's happening? Take aim. Give me your top. Okay, keep it away from your face. Point it over there. Okay. Aim over there. That's good. Give me your top. Go! Take aim. Try not to spill the water all over the stage. Point it a bit. That's it. Okay, put your film containers on the table behind you. It's not gone off. Oh, never mind. Sorry, it's an unexploded one. Let's put it down very carefully. Okay, go and sit down. Give them a clap. In fact, can you get your parents? Go that way, if you like. Go down that way. If the parents of these children wouldn't mind just going to the back, you can go now if you like. Go to the back. Talk to Sam. And just fill in the form so we can use it for the movie. Thank you. Very good. Oh dear, what should we do now? You've been looking at my flying balloon, haven't you? How many people have realised that there's actually a fan here? Yeah, of course there is. There's a fan. It's just blowing cold air, but this balloon actually is flying, and it's really interesting. If you ever get trapped in a lift with 6 scientists, ask them to explain to you why the balloon does that, and they'll all argue about which is the best way to explain it. But it is actually flying, because if I tilt the fan, it doesn't seem to fall off. It will eventually, but it's staying there, quite remarkably. Isn't that surprising? Were you surprised? You need to be able to be surprised to make scientific discoveries. Seriously, every scientific discovery begins with a surprise. That is strange. If I push the balloon away from the air, it comes back into the airstream. Okay. You can try that at home with a table tennis ball and a hairdryer. Another way you can try it is with a drinking straw. Have we got any children who may be a little bit older, who are good at blowing? I need someone who's fairly strong. Have you helped me before? You haven't, have you? Do you want to come up? Okay. Let's see if you can do this. Come and stand. Come and stand here in the light. Now, you hold that. I'll show you what I want you to do. Sorry, it's my fault. Hold that as well. Just hold that. Now watch me. I'm going to do this. See if you can do that. I'll hold for you. Just blow really hard. Excellent, you did it. Okay, that's it. Keep your straw. I'll show you how to annoy your grown-ups with that scientifically afterwards. Go and sit down. Give her a clap. Again, if you could fill in the form. I'm sorry about this. It's a nuisance, isn't it? But if you would. That works really well with Maltesers. You can get these lovely light-scented chocolates to fly. Flying chocolates. Excellent. Do you ever get the feeling that you'd like to break an egg on someone's head? Do you ever get that feeling? Yes? Sorry. Right, okay. Accidentally. My sound system. No, it's working again. Oh dear. I think I need to turn it down. Shall I turn the sound down slightly? Would that help? Yes? Would it? Okay. Accidentally, I broke an egg over the head of a child on the front row a few years ago, and it was very embarrassing. I'm just going to... Sorry. 1, 2, 3, 4, 5. You still hear me? Yes. Can you? Okay, that's better, isn't it? So, what I did was I said, look, if you stick an egg like this and squeeze it like that, it's going to break. Is that okay? Okay. It's going to break over his head. Okay? But I did something very silly. I started talking about the architecture of old church buildings, for example, with dome-shaped ceilings. And I pointed out that an egg is extremely strong in this direction. So if you squeeze an egg from end to end, you can squeeze as hard as you can, and it won't break. You're amazed. Absolutely amazed. But this one, it broke all over the head of the boy in front. It was really embarrassing. I think it must have had a crack or something. But I want you all to go home and try it. Who's going to try that afterwards? Good. Parents will be really pleased with this science of that. Okay, would you like me to show you something 6 times better? 6 times better, okay? 6 eggs, yes. Now 6 eggs should resist 6 times more force. Are you with me on this? Is anyone thinking what I'm thinking? What? Stand on a box of eggs. Right, now listen. I want you all to try this afterwards. Really interesting experiment at home. But you've got to do this experiment on an expensive carpet. Now listen, if you're on a hard floor, a hard surface, you'll briefly transfer all the force onto one egg, and it will break, and then the others will break as well. So we want you to put spread the force evenly by doing it on a soft surface. We could do this this evening. We could have done it, but I don't really expect there's anyone here brave enough to volunteer to stand with a box of eggs. We do have some volunteers. Listen, if you're going to do this, I want somebody who can do this like a ballet dancer. If you're going to wobble around, it's going to be a disaster. This isn't a demonstration. This is an experiment. Think about the difference. We're not sure what's going to happen. Sometimes it breaks. Is anyone here a ballet dancer who can really do this gracefully? Let me see. Yeah, have you helped me before? No, you haven't. Come out to the front. Great. Do you want to come around there? Good. Excellent. What are you wearing on your feet? Let me see. Oh, they're good and soft. They'll be fine. Okay. Sometimes you need to take your shoes off. So there's the eggs in the box. This is a hard floor. So what I'm going to do is I'm going to put the soft pad under here. Let me see you stand on one foot. Which one? Okay, that one. Good. Okay, that's fine. So, let's put the egg box on there. Now come and stand here, like where I'm standing, like that. Okay? Okay, that's good. Okay, give me your arm like that. Now put your foot, stand a bit closer to the box, put your foot on the egg box, let me see. Okay, now brace, let me go for it, that's it. I'm going to let go, I'm going to let go. Give her a clap. Okay, put down. Now don't go away, let's see. Let's have a look and see. Did you feel a sort of crunchy feeling? A little bit. Oh, that's not good. Let's have a look. Let's have a look. Can you hear quiet? Is anyone thinking, hang on, they could be hard-boiled eggs? Put your hand up if you're thinking that. Ones with the hands up are the scientists, okay? You want proof these are raw eggs, don't you? Do you? Okay, now I'm not going to break them all, and I'm not going to break any of them on anyone's head. But would you just choose one and take it out of the box? Okay? We've not met before, have we? No. Okay. Okay, bring it over here. Okay, pass it to me. You stand there so everyone can see. And we'll just see. This is a raw egg. Yes! There we are. Give her a clap. Okay, go and fill in a form, okay? Thank you very much. Good, well done.
So why are there always so many broken ones in the supermarket?
Well, they're just, I don't know, they must be, the supermarket floors are very hard. That must be good. Okay, this is an interesting experiment. I'm going to put some smoke into this bottle. I used to do this with a cigarette, but now using one of these smelly incense sticks. I'm going to light this. Let's see if this works. I'm try and get this burning. These are things that burn and make a lot of nice fragrant smoke in your house. I'm going to push it through a hole in the side of the bottle. Because the idea is I want to fill the bottle with smoke. That seems to be working. Okay. Now, let's see if we can do something interesting with it. See, the bottle's filling nicely with smoke. I'm going to tap the side of the bottle. Tell me if you notice anything happening. Can you see the smoke ring? Let's go over here and do it. Could you see that? Green one. Can you see them? We're making smoke rings. Okay, good. Now, a smoke ring is actually spinning. It's not spinning round and round like a wheel. It's like a tornado. Imagine a tornado, which is like a column of air which is spinning very fast, isn't it? Imagine getting a tornado and bending it round and joining the two ends together. Can you picture that? You'd have a smoke ring, a giant one. Would you like to see a giant smoke ring? Okay. This is a toy called an air-zuka. And I can shoot a powerful smoke ring right across the room. Watch. Did you see that? No, because we didn't have any smoke, did we? The thing is, we can still see the effect because a tornado has got a lot of energy, and so has a smoke ring. Watch this. Oh, I got the Rice Krispies. Hang on. How about that? Okay. There's a lady here with long hair. Would you mind standing up? I'm going to shoot you. Stand there. Anyone else with long hair? Do you want to stand up again? Stand up. Turn your back to me. Okay, watch your hair. Okay. It works at long range. Okay? It's a wonderful toy. It's called an air-zuka. Quite long range. That was good. Long range. There's a very good, there's a firm called Hawkins Bazaar. If you find them on the internet, they sell stuff like this. That costs about £10, I think. Really, really good toy. I've got a whole load more scientific toys I could show you. Let me show you. Yeah, okay, the basketball. I'll show you the basketball before we come to that. Yeah, let me show you this. This is an opportunity to get rich again. Another way of getting rich with an invention. We're going to try and invent a way of getting energy from nothing. Okay? Because the world is running short of energy. We have a world energy crisis. If we could invent a way of getting energy from nowhere, we seriously would be, all of us would be the richest people on the planet. That's a promise, we would. So let's try. First of all, let's think about energy. Energy is actually the same as work. And work involves moving a force. So I've got this force of gravity pressing down against my hand, and I'm doing work by lifting that ball up against that force of gravity. I'm increasing its height energy. It's got that much height energy now. I'm doing more work, and now it's got more height energy. Here's a hard physics question. I'm going to drop the ball and let it bounce. After it's bounced, will it have more height energy or less height energy? You got that right. Did you learn that in the classroom or did you learn that in the school playground? You learn science outside the classroom. You learn it in your cereal bowl, you learn it in the playground. Good. So, let's try that experiment with another ball. This time, most of you are going to get the answer wrong. Okay? I'm quite good at predicting, remember. So, this is a bouncy ball. You know these really super bouncy balls? Yes, you know what I'm talking about, don't you? They really go, don't they? Okay, now, I'm doing the same experiment. I'm increasing its height energy by doing work, pushing it up against gravity. It's got this much height energy. I'm doing more work, pushing it up. It's got this much. When I drop it and let it bounce, will it end up with less height energy or more height energy? Who thinks less? Who thinks less? Who thinks more? Okay, watch carefully. Less. I told you you were going to get that wrong. Okay, most of you, right? The reason you got it wrong was you thought I was going to do something like this. Okay? And by doing that, I gave it some extra energy. When things bounce, they lose a bit of energy, don't they? I could feel the, some of the energy coming through the floorboards on stage when I did that. Okay, now then, all you've got to do to get absolutely stinking rich is to invent a bouncing ball which, when you just drop it, bounces higher. That's all you've got to do. And all the power stations in the world will shut down and switch over to bouncy ball power. They will, and you will become incredibly rich. I've got some ideas. Should we try it now? I've got some ideas. Here's the first one. Suppose if I drop this basketball by itself, it comes back like that. If I drop this by itself, it comes back like that. Now remember, what I said was, all I've got to do is to drop this ball, and it's got to go up higher than it started from, and it's got to get that extra energy from nowhere. If it gets it from somewhere, then it doesn't count, we don't get rich. Okay, should we try? I've got an idea. Let's try doing this. Let's try dropping these together. Are we going to get rich? Let's find out. Let's find out. Are you ready? 1, 2, 3. Hey! Put your hand up if you were surprised by that. Let me see. When I first saw that, I was surprised. Whoa! That can't happen. Are we going to get rich? Did the extra energy come from nowhere or did it come from somewhere? Where did it come from? The basketball. Okay, I think you're right. I think you're right. I'm afraid we're not going to get rich from this one. I've got another idea to try. But if the extra energy came from the basketball, then the basketball should come back up with less height energy, shouldn't it? But we weren't watching the basketball, we were watching the bouncy ball. Let's do it again. This time, watch the basketball. Don't watch this, it'll hit me in the eye or land on this boy's head. Don't watch this ball, watch this once. Because when it drops by itself, it comes back with that much energy. Let's see if it comes back with less energy when this thing goes shooting off the top of it. Are you watching? Watch the basketball. Ready, steady, go. Can someone catch that for me, please? Okay. Thank you. Glad you didn't throw it. Thank you. Okay. So, did you see that? That was interesting, wasn't it? Let's try something else. Have you experimented with these wonderful toys? Doing work, stretching the rubber. That's a clue, by the way. And I put that on there, and a few seconds later, it does that. That's fun. Who's experimented with one of these? Quite a few of you. Watch this. Look, I'm doing work, stretching the rubber, and that's a clue. I'm holding it like this. It's got this much height energy. I'm just going to drop it. Just going to drop it. It went higher, didn't it? Are we going to get rich? Did that extra energy come from nowhere, or did it come from somewhere? Where did it come from? Harvard. I gave you a clue. I said I was doing work, stretching the rubber. It's got stretched elastic energy. It's got elastic energy and height energy. And after I dropped it, it just had height energy. Okay? So we failed again. You're going to keep on trying to invent a way of getting energy from nowhere? If you're successful, you will be really rich. No one's ever succeeded. Okay, some of my scientific toys. Let's just carry on for a few more minutes. This is a nice one. Some of us were looking at this earlier. Let me see. I need 4 girls who haven't helped me before. The reason I'm choosing girls, this doesn't seem fair, but this experiment involves holding hands, and I've discovered that boys and girls don't like holding hands with each other, so to avoid embarrassment, let's have 4 girls. Okay, ones who haven't helped me before. 2 girls there, and, girl there, yes, and girl right at the back there, yes, okay. Yes, you. Okay, can you all come up on the stage? I'll show you this. While they're coming up, let me show you. It's another toy. It flashes and beeps. It looks like a table tennis, but it's something else. Just stand back from the edge. Right back there. That's good. It's got 2 metal contacts on it. If I touch one, nothing happens. If I touch the other one, nothing happens. But when I touch them both, I've made a circuit with my skin. And a very tiny electric current is going round this circuit between the 2 metal contacts and causing the electronics inside to flash and beep. Okay? Now let's see if we can make a bigger circuit. All right? First of all, we'll make a small circuit. You point your finger at me, that finger, put it on that metal contact. Will it beep if you do that? Because we're not in contact, are we? It won't beep, will it? Put your finger on. No. Keep your finger on. I'm going to touch your nose, which is going to become a switch. Watch this. Okay, that's cool, isn't it? Let's try and make a bigger circuit, okay? How are we going to do this? I know. Can you you 2 come around here? Let's make a ring. Don't go too near the edge. Okay, that's good. Okay, that's good. Come a bit closer to me. Okay. Now put your finger on there like you did before, nice and high. Don't touch me. Oh, that's right. Okay. Can you 2 hold hands? Okay. You 2 hold hands. No, you don't hold hands. Come a bit closer to me. Okay. Hold my hand. Okay. Now you touch her nose. Switch off, make it come off and on, go on. Hooray! Okay, mind the stage, give them a clap, go and sit down, and get your parents to fill a form in the back, okay? There are some really great scientific toys. And I think the makers of that toy didn't realise you could do that with it, but it's such a good thing. This is my balloon helicopter. The air from this balloon blows through a whistle here. But some of the air doesn't go through the whistle. It goes through these tubes in the helicopter blades and comes out through these angled nozzles, causing the blade to spin round. Okay? Let's see what happens. This always makes children laugh for some reason. Are you ready? Okay, now let me show you something else. Because I mentioned before that when you start thinking scientifically, you start noticing interesting things, and it really does enrich your life. I've noticed something about this toy, and it's to do with the pressure inside the balloon. Now then, have you noticed when you blow a balloon up, it's hard to start with, and it gets easier as the balloon gets bigger? Have you noticed that? It gets easier. And as the air comes out, it comes out faster at the end. The pressure is greater inside a smaller balloon. It's to do with the mathematics of curved surfaces. The same thing happens with soap bubbles, actually. So, if you wanted to pop a balloon with a pin to give a grown-up a fright, to make the loudest bang, would you pop a really big balloon or a really small balloon? A small balloon. If you pop a great big balloon, you can get giant ones for parties. They don't even pop. They don't. They just come down slowly. If you can manage to blow up one of those tiny water bomb balloons, those tiny things, if you pop one of those, it makes a heck of a bang. Really. So, as this thing gets up near the ceiling and the last bit of air comes out through the whistle, if the pressure increases, what's going to happen to the sound the whistle makes? Yeah? Do you think it will get louder? I think it will. Do you think the pitch will get higher? Yeah? I think it will. Let's listen. Now this time you're forbidden from laughing. Nobody is allowed to laugh. Nice and quiet. Choke if necessary, but don't laugh. Listen to the sound this makes as the last bit of air comes out. Listen. Did you notice? Right? Okay, good. Now there's another toy. Do you ever go to boring parties where all the grown-ups are talking about boring things? Yeah? I've got the cure for parties like that. I've got something which makes even the most boring grown-up start acting like an 8-year-old, okay? Seriously, it's really good. It's called the rocket balloon, okay? You go into a boring party, take some of these in your pocket and let them loose around the room, and it stops the grown-ups from being boring. They've got strange sort of nozzles, these balloons. This is what makes the funny sound. And to blow them up, you have to put a piece of drinking straw in to blow them up, and then take the straw out before you release it. They make a terrible bang when they burst these because of the small radius of curvature. Okay, that didn't bang. Okay, now if I point it that way and let go, the air is going to go that way. Which way is the balloon going to go? That way. Whoa, sorry. Well, that was fun. Should we do another one? If it hits you, turn it round quick and send it up again. Okay, this way. I'll try. I never know which way it's going to go. Oh! Oh, great. Excellent. Oh, that was fun. Did you notice, by the way, as the last bit of air came out, did you notice it jumped forward? Did you notice that? If you didn't, I'll do another one, okay? This time, watch, as the last bit of air comes out, you'll see the pressure increase, the pitch goes up and it jumps forwards. And now I've pointed this out to you, you'll always notice it afterwards. Let's see if we can see what happens at the end. This one's going to spin around, I think. It did. Okay. When grown-ups buy presents for children, sometimes they spend too much money. You can buy toys nowadays in fancy boxes with big, lovely pictures on the lid. Sometimes they're even supposed to be scientific. And they're very expensive, and when you open the box, what's inside sometimes isn't nearly as nice as the picture on the lid. You know what I mean? But some toys are just wonderful, and they're cheap, and you can play with them for ages. This is an example. Do you know what this is? It's a stick helicopter. Lots of toy shops sell these, but you probably don't know what they are. They're usually sold in 2 bits, like that, shrink-wrapped. Look out for them, they're wonderful toys. You can do this with them. Like that. How about that? Isn't that good? Don't fly it back. Could you just bring it back and put it on the stage for me, please, okay? Whoops! Okay. I'll have to add that to my risk assessment. Yeah, thank you. Okay, we're coming to the end now. I'd better just show you. Would you like me to show you some ways of annoying grown-ups scientifically? Okay. Okay. Well, one way is to make a strange noise. Now, this is actually, I've added this to my routine because I've just discovered how to do this. If you're going to experiment with one of these at home, I think you better get a grown-up to help you. That's a sound, but it's not a very nice sound, is it? Okay? It's not a very pure sound. Let's try bending it. That's a bit better, but still not a very clean sound. If I bend it in an S shape, I've now got a springy bit here and a springy bit here, and this flat bit here is completely free to vibrate. Listen. And I can change the pitch by changing how much I bend the saw. That's quite nice. But there's another way, which is really cool. I've only just learned how to do this. And I can play it like a violin. How about that? Now, when a violin bow, you rub it with resin. These are actually strands from a horse's tail. Did you know that? And they're rubbed with resin, which is slightly sticky. And when it rubs over the violin string, it sticks and slips, very, very fast, causing the string to vibrate. And vibrations cause sounds, don't they? And the same happens with the metal of this saw. Listen to this. I can't play a tune because I'm not a musician, but listen to this. How about, isn't that cool? I'd get more applause if I could play a tune, wouldn't I? Now then, you can do this also with a wine glass. Now, some of you will know this experiment. It's really, really a great way to annoy grown-ups at meal times. In fact, there's probably no better way of annoying grown-ups at meal times when there's a wine glass on the table. Now, a wine glass is shaped like a bell, isn't it? Yes? And it rings like a bell. Now, if I hold it here, it doesn't ring because it can't vibrate freely. Just like a bell, but when I hold it down there, it can vibrate freely. Now, another way to make glass vibrate is to rub it with a wet finger, because it squeaks, doesn't it? We say the glass is squeaky clean. It works just the same way as the violin bow and the violin string. It sticks and slips very fast, causing a vibration, which we hear as a squeak. Can you hear this? That was a squeak. Now, I was pressing so hard on the glass that it was squeaking, but it wasn't ringing. If I press really lightly, I can change that squeak into a ring. Listen to this. That's a really loud sound, isn't it? Now, you can learn to do this. Who's going to try this at home afterwards? Oh, good. And listen, if you're in a restaurant listen, this is such a pure sound. If you close your eyes, you can't tell where that's coming from, can you? Not really. It's such a pure sound. The sound seems to surround you. The way our sound location mechanism works, pure sounds like that, we can't tell where they're coming from, which is really handy if you do it under the tablecloth in a restaurant. Who's going to try that? Yes. Very good. Okay. Good. Now, the final, ultimate way of annoying grown-ups scientifically involves a drinking straw and a pair of scissors. This is really, really cool. Pay careful attention. Take your drinking straw, take your pair of scissors, flatten the end of the straw between your thumb and the edge of the scissors. Do you see how I'm doing that? Just flattening it against the blunt edge of the scissors and make it flat. It's quite hard because it's springy plastic, and when you've made it flat, you cut it to a point, like that. Okay? And when you cut it to a point, you've got a shape like this. I don't know if you can see, but I've cut it to a point, and from the side it looks like the jaws of a crocodile, doesn't it? You see that? Now, if I put that in my mouth with my lips around here and blow through it, that way, the two flaps snap shut, and then the air stops flowing through. So they spring open again. Then the air starts flowing through again, and they snap shut again. And this happens so fast, we get a vibration. And what do vibrations cause? Sounds. And this particular sound drives grown-ups balmy, okay? So I'm not going to blow it, okay? I'm going to need some help. Quietly, there we are. Okay, just a couple there. Okay, there. Sorry. Look, I'm going to have to just throw these. Can you just...
You can't all have one, I'm afraid.
You can't all get one.
I've shown you how to make them. Put the cut end in your mouth and blow really hard, okay?
There we are.
That's it. More of that. Yeah.
What's over here? There we are. Grown-ups are allowed them as well. Who wants one? Good. Anyone else? Very good. Right, put the straws away. Put the straws down your trousers. Put the straws up your jumper. Put the straws up your sleeve. Because if a grown-up sitting near you sees one, they're going to take it off you. Someone's going to lose their straw over there. Put them away, nice and quiet. Now then, we're coming very close to the end. I've shown you lots of ways to explore science yourself. This stuff on the table isn't just silly stuff. This is real science. Some boring grown-ups don't agree with me, but they don't understand that real science is about experimenting. And that's what we've been doing today. Now, let's just explain about experimenting. Experimenting, many boring grown-ups think that when they're doing it, it's experimenting, and when you're doing it, it's mucking about. Okay? That's not fair, is it? Is that fair? No. You are very good at experimenting. That's what we've been showing this evening. This is what science is really about. Well done. So keep on experimenting. Now then, as you get older, there's a terrible danger of you becoming more boring. Isn't there? Think about it. That's terrible. This kind of science is the best cure against getting more boring as you get older. That's true, okay? So stay interested in stuff like this. Okay? Good. Children are better than grown-ups at science. They're better at noticing things, they're better at being surprised, better at experimenting, and they're less boring. That's true, isn't it? Okay, now then, there's one experiment you mustn't try at home. Absolutely mustn't. Well, you mustn't go jumping off the roof with the bottle. That was a bit of a silly idea. Jumping out of a plane with a magnifying glass, also not very bright. And what else? Oh yeah, you do the egg experiment at home. Maybe not on the best carpet. That was just being a bit silly, wasn't I? And there's one experiment you absolutely mustn't do at home. Which one is that? Yes, the exploding custard. Now then, custard powder tends to absorb water vapour from the air, and that makes it slightly damp. So I've actually got some more. This is the same stuff as this, but I dried it in the oven for a few hours to get rid of all the moisture from it, so it's nice and dry. And I kept it with a lid on so that you can see how dusty it is. You can see the dust coming out from there maybe. It's very, very dry powder. We have to keep our powder dry. Don't blow the straws yet. You can blow the straws at the end. I'm going to put just a little bit of custard powder in here. We don't want to put too much in, because the people at the front don't want me to, do you? What? A bit more? Okay. Look, this is dangerous. This is custard. All right. What? Oh, are you sure? Okay. Okay. No. Just a tiny... No, I'm getting nervous now. No. Sometimes when I do this in schools, I say, you don't want me to blow your school up, do you? A bit of a silly question, really, isn't it? Okay, I'm going over here. Goodbye. Are we ready? Are you sure? Let's get that funnel absolutely straight. That's it. There we are. Yep. Okay, that's good. 10. 9, 8, 7, 6, 5, 4, 3, 2, 1. Thank you very much. Bye.
I think what I like most about events like this is the fact that they're family audiences. When children are with their parents, there's a different chemistry. The atmosphere tonight has been quite electric, really, and there are all kinds of wonderful interactions between children and adults together when they're sharing something like this. So I think the intergenerational nature of a science festival is actually really precious. I enjoy doing this. It's just such fun, and it's so nice and encouraging when people come up to you, what the grown-ups coming up to thank me, although I don't know if they'll thank me when the kids get home and start messing up the kitchen, and the children are just buzzing, and they're going out quite unlike the way they came in. They were quite a quiet audience when they came in to start with, weren't they? And they went out very, very noisy. So something happened there, didn't it?